math learners, Hassan here. Today we are diving into compound inequalities. You'll see how they allow us to set dual boundaries in the language of mathematics. So let's start.
Okay, so let's start. A compound inequality is an inequality formed by joining two inequalities with the word and or the word or. We'll see the difference between these two types of inequality in a moment. But here is how the problem could be presented to us. We can have two inequalities separated by and or separated by or. Now let's see how the graph of a compound inequality with and would look like. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. The graph would show the numbers that are solutions of both inequalities. Let's see an example over here. Here we have x greater than or equal to 2. So you can see over here, this is 2. And we have just made a closed circle and go all the way to the right. And here we have x less than 5. So here we have 5. We just go all the way to the left. Now, the end part would give you the intersection of these two inequalities. So if you have the intersection, it would look like this. This is the intersection part between this portion and this portion. So this black section is the intersection of these two inequalities. Now, we can see that if we have the compound inequality with and, we can also rewrite this as the minimum value less than, or you can have less than or equal to, then the variable x less than or equal to maximum value. This is applicable for the compound inequality with and. You can see that this 2 is the minimum value and this 5 is the maximum value. This is the intersection part between these two inequalities. Now we'll see the graph of a compound inequality with or. The graph of a compound inequality with or is the union of the graphs of the inequalities. In this case, the graph would show the numbers that are solutions of either inequality. Let's look at an example over here. Here we have y less than or equal to -2. And here we have y greater than 1. So in this case, this graph is going all the way to the left, and this graph is going all the way to the right, and there is no intersection. So the combined inequality would be this union section, which is this one going all the way to the right, and this one going all the way to the left. So here we have y less than or equal to -2 or y greater than 1. So in this case, we don't have any intersection. So remember, if we have any intersection, that's and if we don't have any intersection, we have or for the compound inequality. Now let's look at some of these strategies to solve these types of problems. So the first thing is, whenever we will be presented with the compound inequality, we separate the compound inequality into two inequalities and then solve each one individually. The second one is we combine the solutions based on whether it's an and or compound inequality. So if we have and, we just make the merge, and if we have or, we just make the union. So for and, we just find the overlapping region between the two solutions, and for or, we just find the non-overlapping region between the two solutions. Now let's see a practice problem over here. Remember, we just mentioned that for and compound inequality, we have the format minimum less than or equal to the variable, and then less than or equal to max. This is the structure of and inequalities. So you can see that this is the similar structure over here. So here is how we can solve this problem step by step. So we first break this down into two inequalities. So we have -4 less than x minus 2. So we just take this portion. We have this inequality, and we have the second portion, x minus 2 less than 3. So you just write these two inequalities. Now we just follow the process of solving one step, two step, or multi-step inequality. So for the left one, we just add 2 on both sides. Over here, we just add 2 on both sides as well. And then we have negative 2 less than x, and this one x less than 5. So this negative 2 less than x, let's try to see this on a number line. So let's say over here we have this negative 2. Negative 2 less than x can be written as x greater than negative 2. For inequality, if we swap the sides, the inequality symbol would reverse. So negative 2 less than x is same as x greater than negative 2. So just make an open circle and go all the way to the right. And this one, x less than 5, let's say 5 is over here. In this case, we also make an open circle for 5 and go all the way to the left. So the overlapping region is this section. So if you want to graph this solution, we have negative 2 to 5, and both would be an open circle over here. Awesome. So keep in mind that negative 2 less than x is same as x greater than negative 2. It is always the standard to keep the variable on the left side when it's a single inequality, but when it's a compound inequality, we just follow the format of minimum less than or equal to the variable, and then less than or equal to the maximum value. And here is another important note that a compound inequality with AND can be written as a single inequality. Now this is not applicable for the compound inequality with OR. We can only write the AND inequality as a single inequality. Let's try to solve this problem over here. We have 3y minus 5 less than negative 8, or 2y minus 1 greater than 5. After solving, we need to graph the solution as well. So first we write down these two inequalities, and then for the left inequality we just add 5 on both sides. And for this one we just add 1 on both sides. Once we do that, we get 3y less than negative 3. For this one we get 2y greater than 6. So then we divide both sides by 3. We get y less than negative 1. Over here we get y greater than 3. So if we draw this on a number line, we get, let's say here is the negative 1. Y less than negative 1 is all the way coming to the left, and y greater than 3 is coming all the way to the right. So this is how we solve the inequality and graph the inequality. Okay, so here the problem statement says that solve each compound inequality and graph its solution. So here we have these strategies to solve. So the first problem is negative 1 less than 9 plus n less than 17. And here we have the number line to graph the inequality. So the first step is we separate the compound inequality into two inequalities. So let's try to separate this. We have negative 1 less than 9 plus n. So here we have this inequality represented as a single inequality. So we can write this section as one inequality and this section as another inequality. And this kind of inequality is represented by AND inequality. So we have this AND inequality, 9 plus n less than 17. So now the next part is we solve each of these variable. So in this case, here we need to remove this 9, so we subtract 9 from both sides. If we subtract 9, we have -1 minus 9, that is -10, less than n. And here we subtract 9, so we have n less than 17 minus 9, that is 8. So you can write this as -10 less than n and n less than 8. So this can be written as a single inequality. We can write this as -10 less than n less than 8. We can take this variable as a common variable and write it at the center. So now we have this -10 right here, and we have this 8 right here. Since this n lies between -10 and 8, we shade this region, and we keep the circle open because there is no equal sign in any of the inequality sign. So this kind of inequality can also be solved without separating these two inequalities. So we need to find a way to get n at the center, since solving the inequality means having a variable with a coefficient of 1. So I just need to get n by itself. So in this case, I see that I need to remove this 9. And to remove this 9, I just need to subtract 9 from here. So when I subtract 9 here, I need to subtract 9 on this side and also on this side. And when I do that, I see that I get n here, and I have -1 minus 9, that is -10. And here I have 17 minus 9, that is 8, which is exactly same as this inequality. So you can see that we can solve these kind of inequalities in either ways. We can separate the inequality, or we can keep the same inequality and get rid of the terms to isolate the variable. So now let's see the next problem. Okay, let's work on number 2 here. We see that we have -3p plus 3 less than 3p minus 3 and -3 plus 2p less than or equal to p plus 6. So here the two inequalities are already separate, but we know that the inequality is the AND inequality. And let's see how we can solve this. So here we see that to solve this part, I just need to get this 3p onto the left side. So I subtract 3p on both sides, and I have -3p minus 3p, that is -6p plus 3 less than this 3p cancels out, minus 3, and I take this 3 onto the right side, so subtract 3. If I do this, I get -6p less than -6. And we can see that to get p by itself, I just divide both sides by -6. Since we are dividing both sides by a negative number, we just reverse this inequality symbol. So we have p greater than -6 divided by -6, that is 1. And let's try to do this part. Here we need to take this p to the left side, so subtract p. If I do this, I get -3 plus p less than or equal to 6. And to take this -3 to the right side, I just need to add, because the sign in front of 3 is a negative sign. So I need to add 3 so that I can cancel out this term. So I have p less than or equal to 9. Since this inequality is represented by AND inequality, we can see that there should be an overlapping region. So you can write this inequality as a single inequality. I can see that this is the minimum value, which is 1. So I just write 1 here, and then I have less than symbol. Then we write the variable at the center, and then we have this less than or equal to the maximum value, which is 9. So I have 1 here. I just keep a circle on 1. Now that should be an open circle because there is no equal sign. And then I have this 9 right here, and we just keep it closed because there is an equal sign. And then we just shade this region. Again, a quick note here is that p greater than 1 is same as 1 less than p. We can rewrite this inequality by reversing the side. So p greater than 1 is same as 1 less than p, and we have this p less than or equal to 9. We can just combine these variable at the center and we get this pattern. Perfect. Now let's try to work on number 3. Number 3, we can see that we have -2 minus x less than 3x minus 6 less than or equal to 2x plus 3. So to start off, we can just separate these two inequalities. So we have this inequality written here, and we have this inequality written here. Again, we can see that we have an overlapping region since this inequality is written as a single inequality. So we need to solve for this variable x and then find the overlapping region here. So first, let's see how we can get this variable x. So here we can take this 3x to the left side first. So we subtract 3x. So you can simply add those two numbers and keep that same sign. So we have 1 and 3 added together to make it 4. But since both have a minus sign, so you keep that minus sign. So -2 minus 4x less than -6. Now we take this -2 to the right side and we take these by adding 2 on both sides. If we add 2, we get -4x less than -6 plus 2, that is -4. And to get x by itself, we divide both sides by -4. Since we are dividing by a negative number, we get x greater than 1. -4 divided by -4, that is +1. Now over here we have another inequality, 3x minus 6 less than or equal to 2x plus 3. So we take this 2x to the left side, we put a subtraction minus 2x on both sides. We have 3x minus 2x, that is x minus 6 less than or equal to 3. And we take this 6 to the right side by adding 6 on both sides. We get x less than or equal to 9. Now you can see that here the minimum value is 1 and the maximum value is 9. So x should lie between 1 and 9 since this is an inequality. So we can reverse this inequality. We can rewrite this as 1 less than x. So we have the same inequality represented like this. X greater than 1 is same as 1 less than x. And we have this x less than or equal to 9. So you can rewrite this as 1 less than x less than or equal to 9. So here we have this 1 and here we have this 9, and this 9 will be closed because we have this equal sign underneath the inequality sign. And then we just shade this region. Perfect. Let's look at this problem number 4. We have this OR inequality here. We see that 4 plus 4m less than 6m plus 2, or 4 minus 6m greater than or equal to 2m plus 4. So one inequality will go in the left direction and the other inequality will go in the right direction. So the same case will be applicable for number 5 as well. You can see that we have this OR inequality. So let's try to see how we can solve this. So let's first write down this inequality. Now to solve for the variable, we need to get the variable term to the left side and the constant term to the right side. So First, bring this 6m to the left side and we apply subtraction. So if you apply subtraction, we have 4 minus 6, that is negative 2m. And since there is a plus sign, so plus and this negative sign will have a minus sign, and we have this 4. So 4 minus 2m less than 2. And then we take this 4 to the right side, we subtract 4. If we subtract 4, we get negative 2m less than 2 minus 4, that is negative 2, and divide both sides by negative 2, we get m greater than 1 because we are dividing by a negative number, so we reverse this inequality symbol. And let's try this one. Here we have 4 minus 6m greater than or equal to 2m plus 4. So subtract this 2m from both sides. So we have 4 minus 6m minus 2m. So since both are minus, we just add those coefficients and keep the same sign. So 6 plus 2, that is 8m. So we have 4 minus 8m since both are subtraction, greater than or equal to 4. Subtract 4 from both sides, we have negative 8m greater than or equal to 4 minus 4, that is 0. If we divide both sides by negative 8, we also get 0, but remember that we are dividing by a negative number, so the sign would reverse. In this case, it would be m less than or equal to 0. We have m greater than 1. So here we have m greater than 1. The greater than section would be going into the right direction. And m less than or equal to 0. Here we have this 0. We circle this 0 and make it closed because there is an equal sign. And this one is less than or equal to, so it will go in the left direction. We can see that there is no overlapping region between these two inequality, and there is a gap at the center. So the same case will be applied in number 5. Let's see how we can solve this. Now to solve this variable, we take this 4p to the left side. We subtract 4p. Now this is negative 3p minus 4p. We have negative 7p minus 4. And 4p cancels out here. We have greater than 3. So we cancel out this 4 by adding 4 on both sides. If we add 4, we get negative 7p greater than 7. Now to get p by itself, we divide both sides by negative 7. We have p less than negative 1 because we are dividing by a negative number, so the sign would reverse. And 7 divided by negative 7 is negative 1. Let's try this one. We have 1 plus 3p greater than or equal to 1 minus 2p. We have to take this 2p to the left side, so we add 2p since the sign in front of 2p is a minus. So adding 2p on both sides, we get 1 plus 5p greater than or equal to 1. And we take this 1 to the right side, we subtract 1 on both sides. We get 5p greater than or equal to 0, since 1 minus 1 is 0. And to get p by itself, we divide both sides by 5. We get p greater than or equal to 0. Now let's try to plot these two inequalities. P less than negative 1. We circle this negative 1, and since it's less than symbol, it will go to the left direction. And p greater than or equal to 0, we circle this 0 and make it closed. because there is an equal sign and we take it to the right direction. Again, we can see that there is a non-overlapping region, which is this central region. So this is how we make a distinction between AND inequality and OR inequality. I hope this has been helpful, and I'll see you in the next one.
And there you have it, the exploration of compound inequalities unveiled. Keep practicing this topic with our practice question set. That's it for this video, and I'll see you in the next one. Now let's get to study.